Hello, this is Dr. Hanaa Assil, and these are questions and answers on chemical calculations. This is mainly for the AS Chemistry of the International Advanced Level IGCSE. So, these questions are based on the equations and the things you're required to know for chemical calculation. So the main thing we do in the chemical calculation is calculating the number of moles, and you should realize that we have several equations that we use to calculate number of moles. So either number of moles is mass over molecular mass. So in that case, you can also use it to get the mass in grams, number of moles times the MR. Or if we're talking about gases at room temperature and pressure, we said that the number of moles would be the volume over 24. The volume is in decimeter cubed. If you're required to get the volume, it is number of moles times 24. If we're talking about solutions, then the number of moles is concentration times volume. In that case, the number of moles, concentration times volume, you can also use that equation to get concentration, that is number of moles over volume. So basically you're required to know these equations. You are also required to know the use of Avogadro constant, and you know that Avogadro's constant is 6.02 times 10 to the 23. This gives the number of molecules. So if I want number of moles, it would be the number of molecules over 6.02 times 10 to the 23. So that is if we want number of molecules, not number of moles. For gases, volatile liquids at a certain pressure, temperature, volume, and so on, we use the ideal gas law, PV equals nRT. So the number of moles is the pressure times the volume over R, which is a constant, times T, and you need to pay attention to the units. The pressure should be in Pascal, the volume in meter cubed, the temperature in degree Kelvin, and R is a constant, 8.31. Okay, let's start questions. A basic question would be, define the term relative atomic mass. You know that the basic calculations is I should be able to calculate molecular mass, so that uses the relative atomic mass, and you should know that the relative atomic mass, which is the mass number that we have in the periodic table, it is the average mass of atoms of an element relative to 1/12 of the mass of a carbon-12 atom. This is the atom that we use as a reference. So we use the carbon-12 as a reference to determine the average mass of atoms of any element. This is a question, a basic question, and it says zinc oxide was reacted with dilute sulfuric acid to prepare zinc sulfate crystals. The formula of hydrated zinc sulfate is this: calculate the molar mass. So basic chemical calculation involves the calculation of the molar mass, which we represent by MR. That is the total masses of all the atoms, and you get that from the periodic table. So if we're required to get the molar mass of zinc sulfate, 7 water, we get the mass number of zinc. I'm going to remind you that the mass number is the big number in the periodic table. So zinc is 65.4, sulfur is 32.1, oxygen is 16 and I have 4 of them in the zinc sulfate. And then I have 7 water. All of this is added together to get the MR. So 7 of H2O, that means I have 14 H's, each of them has a mass of 1, and 7 oxygen, 7 times 16. So the total of that is what we call the MR, or the molar mass of the compound. Then the question says, calculate the number of moles of sulfuric acid in 20 centimeter cubed of 1 mole per decimeter cubed solution. I would suggest that from now on, you can stop the video when you see the question, try doing it on your own, and then continue to determine whether your answer was right or wrong. So here we're saying calculate the number of moles, and we're given 20 centimeter cubed. You should know that anything in centimeter cubed, that's the volume, of 1 mole, decimeter to the -3, or we call it mole per decimeter cubed. That is concentration. So we're given volume and concentration, and I want to get number of moles. So your first question would be, which equation are we going to use? Well, you should realize that we're going to use the equation that says number of moles is concentration times volume. You have to pay attention that the volume that we put in any of the equations we're talking about should be in decimeter cubed. Now, usually he will give you the volume in centimeter cubed, so you need to divide that by 1,000 to change it to decimeter cubed. And then you multiply concentration times volume, so that gives you the number. So the question says they were trying to make zinc sulfate, and when they did that, they ended up with 4 grams of the hydrated zinc sulfate. Calculate the percent yield. So what they did was they reacted zinc oxide with sulfuric acid, and we already calculated the number of moles of sulfuric acid in that previous question, and we got it 0.02, and from the equation the number of moles of the zinc sulfate obtained as a product should be the same as number of moles of sulfuric acid. So number of moles of zinc sulfate is 0.02. I can use that to calculate the mass that should be obtained, which we call theoretical mass. So from this number of moles, how do we get mass? You should know that mass is number of moles times MR. Number of moles is what we got, 0.02. The MR was what we calculated in the first part of the question, so that was 287.5, and that means that the theoretical yield is 5.75. What we should get is 5.75, but when they did it, they got how much? They got 4 grams, then the percent yield is the actual yield that was obtained, which is 4 grams, over the theoretical yield that should be obtained according to calculation. So that's 5.75 times 100, and that means the reaction was a 70% yield. Okay, this is another question. What is the concentration in mole per decimeter cubed of a solution containing 7.84 grams of phosphoric acid in 400 centimeter cubed of solution? Again, you could stop here for a minute. We're trying to get what? We're trying to get concentration. And you should know concentration is number of moles over volume. But we don't have number of moles, so we need to get number of moles. We are given what? We are given 7.84 grams. Then I can say that the number of moles of the acid is mass over molecular mass. The mass is 7.84. The molecular mass, you add up all the masses from the periodic table, 3 hydrogens, 1 phosphorus, and 4 oxygens. This comes out to 7.84 over 98, and therefore I get number of moles is 0.08 mole. So now I have number of moles, and we're given the volume, and we're required to get concentration. So concentration is the number of moles over volume. Please do not forget to change the volume to decimeter cubed. So the 400 over 1,000 should be 0.4, and that gives me a concentration of 0.2. Okay, what about this one? Another type of question is where we are required to get the empirical formula or the molecular formula in some questions. So here the question says, a sample of a hydrocarbon. I'm going to remind you that the word hydrocarbon means my compound has only hydrogen and carbon. Hydrocarbon with a total mass of 7.2 grams. Now, we're told that in the 7.2 grams, this contained 6 grams of carbon. What is the empirical formula? So the first thing you need to decide, how much hydrogen do we have? If we have a total 7.2, 6 grams carbon, then the hydrogen is 1.2, the rest of the 7.2. Now, to calculate empirical formula, we go through 2 main steps. The first is divide by the mass number. So we're going to divide each of these by the mass number, the carbon by 12 and the hydrogen by 1. And the numbers that come out, I divide by the smallest because I'm trying to get the simplest ratio. So divide through by 0.5, that's the smaller of the 2 numbers. And that means I end up with what? I end up with 1 and 2.4. Now, if we have 2.3 or 2.4 or 2.5 or 2.6, do not round them up. Don't say that's 1 to 2. No, it's not 1 to 2. If it is something in between like this, then we need to find a number that I can multiply throughout to change it into a whole number. So what can I multiply 2.4 with in order to get a whole number? You will find that I will need to multiply by 5. So you multiply all through by 5. And that means it is not 1 to 2.4, it is 5 to 12. And that means my empirical formula is C5H12. So if you divide by the smallest, we said the 2 steps are divide by mass number, divide by the smallest. Now when you divide by the smallest, you're supposed to get a whole number. So if the number is something 0.0 or something 0.1, that's okay. So if this were 2.0, 2.1, I would have said it's 2. If it is 2.9 or 2.88 something, you can say it's 3. But if it is somewhere in between, you have to decide that you're going to multiply by a number all through to make them a whole number. Okay, this is another kind of questions in which the question says which pair of substances contains the same number of moles at room temperature and pressure. Remember that we said room temperature and pressure, the number of moles is what? The number of moles is volume over 24. So we need to use that to calculate the number of moles of each one. And the question wants, in which choice do we have both substances having the same number of moles? So basically, what you're given, you're going to get the number of moles. If we're given 24 decimeter cubed of chlorine, then the number of moles is volume over 24. So it's 24 over 24, so that means I have 1 mole. What about 20 grams of calcium? How do I get the number of moles of that? We said number of moles can be mass over molecular mass. So the mass given over the MR of calcium, or the mass number of calcium, that gives this number of moles. And this choice, both of them are different. We're looking for where both of them are the same. So let's see choice B. Choice B is talking about oxygen, 24 decimeter cubed of oxygen. Again, that means 24 over 24, that's 1 mole. And then I have 14 grams of lithium. We use mass over molecular mass, and the mass number of lithium is 7. So that gives 2 moles. Again, they're not the same. What about choice C? We have 1.2 decimeter cubed of hydrogen, volume over 24, gives me a certain number of moles. What about the 2.7 grams of aluminium? Well, that's mass over molecular mass. That's a different number of moles. What about choice D? 1.2 decimeter cubed means 1.2 over 24. That gives number of moles. 1.2 grams of magnesium is mass over molecular mass, and that gives the same number of moles. So that's my answer. Then this question says, calculate the number of bromine molecules in 2 grams of bromine. Remember, we said the number of molecules we can get from the Avogadro's constant, and we should know that 1 mole of a substance has 6.02 times 10 to the 23 molecules. So we need to get first the number of moles of the bromine. So how do we get number of moles of bromine? We have 2 grams. That means I'm going to say mass over molecular mass. Remember that here the bromine is Br2, so you need mass number times 2 to get the MR. Then that gives us the number of moles of bromine. How do we get number of molecules? We just multiply that by Avogadro's constant, 6.02 times 10 to the 23. That gives me the number of molecules of bromine. Then this question says a sample of bromine gas occupied 200 centimeter cubed. Of course, that's the volume, at a temperature of 77 degrees Celsius and a pressure of 1.51 times 10 to the 5 Pascal. Calculate using the ideal gas equation the number of moles of bromine. We know that the ideal gas equation is PV is equal to nRT, where N is the number of moles, so we can use that to get number of moles. Number of moles is PV over RT. Again, please remember the units. The pressure should be in Pascal, but the volume should be in meter cubed. We are given in centimeter cubed. So if we have the volume in centimeter cubed, I have to multiply by 10 to the minus 6 or divide by 10 to the 6 in order to change it into meter cubed. The temperature is given in degrees Celsius. We never use a temperature in any of these equations in degrees Celsius. We add 273 to change it to Kelvin. Then we can put the numbers into the equation. So the pressure is 1.51 times 10 to the 5 Pascal. We put the volume in meter cubed divided by R. R is always 8.31, so it's a constant. And the temperature we got is 350 Kelvin. That gives me number of moles is 0.0104 mole. You could either leave it like that or put it in what we call the standard form. Okay, let's take a look at this question. Magnesium chloride can also be made by reacting magnesium oxide with dilute hydrochloric acid. Calculate the minimum volume of hydrochloric acid needed to completely react with 2.45 grams of magnesium oxide. So we are given information about magnesium oxide and we're asked about hydrochloric acid. So the first thing we do, we use the information about magnesium oxide in order to get what? In order to get number of moles. Now, which equation are we using? Mass over molecular mass. Of course, the molecular mass, again, you calculate from addition of the masses. And this gives me the number of moles of magnesium oxide. Now, I need to look at the equation. Can you see the equation? What is the mole ratio of magnesium oxide compared to HCl? You can see that the equation says 1 mole of magnesium oxide needs to react with 2 moles of HCl. And that means if I have the number of moles of magnesium oxide, then the number of moles of HCl is twice of that. So now I have number of moles of HCl. Then what are we required to get? We're required to get the minimum volume that is needed, and we have the concentration, and you should know that volume is number of moles over concentration. Remember, this is a solution, and we said number of moles is concentration times volume. That means volume is number of moles over the concentration, and that gives me what I get from that is in decimeter cubed. But we are required to get it in centimeter cubed. Remember, what comes out of these equations, volume is in decimeter cubed. Now, to change it back to centimeter cubed, I need to multiply by 1,000. Okay, then this question says, calculate the mass of magnesium chloride that could be formed when 2.25 grams of magnesium carbonate is added to excess dilute hydrochloric acid. So now we are given the mass of magnesium carbonate we're starting with, and we're required to calculate the mass of magnesium chloride formed in the product. Again, we have mass of magnesium carbonate. The first thing we do is number of moles. Mass over molecular mass will give the number of moles. So that is the number of moles of magnesium carbonate. Then I look at the equation. What is the mole ratio between that and the magnesium chloride? Obviously, from the equation, 1 mole of magnesium carbonate will give 1 mole of magnesium chloride, and that means the number of moles of magnesium chloride is the same as the number of moles that we calculated for the magnesium carbonate. Now I have number of moles. We're required to get what? We're required to get mass. Then mass is number of moles times mR of the magnesium chloride, and that gives me a mass of 2.54 grams. Were you able to calculate it on your own? Okay, let's try this one. Ethane dioic acid is a solid diprotic acid. Just ignore all of this if you haven't done organic yet. A student used ethane dioic acid in a titration to find the concentration of potassium hydroxide. So we have the ethane dioic acid is that acid that has COOH twice. And we're reacting it with potassium hydroxide. And the question is, calculate the mass of acid that should be used to make 1,000 centimeter cubed with this concentration. So I need to make this volume with this concentration, and we're asked for the mass. So of course, again, the first thing I need to calculate is what? Number of moles. number of moles, concentration times volume. Again, remember the volume should be in decimeter cubed. So you multiply that by, you divide that by 1,000. And that gives me 0.05 mole. That means that's the number of moles I want. Then I need to calculate the mass. How do we get mass? Number of moles times MR. So that number of moles we got times the MR of the compound, which is already given. Please check to see, sometimes we are given the molar mass so that you don't need to sit down and calculate it. So that gives me a mass of 4.5 grams. Okay, let's try this question. A mass of 0.64 grams of iodine reacted with fluorine to form a total of 1.31 grams of a fluoride of iodine. Calculate the empirical formula. So I have the mass of iodine, but how do we get the mass of fluorine? It is the rest of the total mass. If the total mass is 1.31, then the mass of fluorine is the difference. And that gives me mass of fluorine. Then I can start calculating. I have iodine and fluorine and I have the masses, and we said we go through two main steps. The first is divide by the mass number of each one. So this is the mass number from the periodic table. What comes out, I divide by the smallest. Which one is the smallest? Sometimes the mistake is I don't choose the smallest. Which one is the smallest? 0.005, that is smaller than 0.03, remember? So that gives a ratio of 1 to 7, and that means, please don't stop here. We are required to give the empirical formula. So if I say the ratio is 1 to 7, what is the empirical formula? It is IF7. So that's my answer. Okay, another question. How many ions are in 284 grams of sodium sulfate? Now we said the Avogadro constant is the number of what? This is the number of molecules. Remember that. Avogadro constant is the number of molecules, or the number of atoms if I have only one atom, or the number of ions if I have only one ion. But otherwise I have to get the number of moles and multiply the Avogadro's constant with that. So what do we have? We have 284 grams. I need to get number of moles. Number of moles is mass over molecular mass of the sodium sulfate, and we're given, so that gives me 2 moles. We're asked to get how many what? How many ions? Now, I have 2 moles of sodium sulfate. Now, each sodium sulfate has how many moles of ions? You should realize that if I ionize sodium sulfate, it will give 2 sodium ions and 1 sulfate ion, and that means 1 mole of sodium sulfate gives 3 moles of ions. And that means the number of moles that I have, I multiply by 3, so actually I have a total of 6 moles of ions. Multiply that by the Avogadro constant, that gives the number of ions. Are we following? Okay, next question. Calculate the empirical formula when I have lithium with this percent, phosphorus this percent, and oxygen this percent. So again, how do we calculate empirical formula? We write them out like this. Divide first by the mass number, which is already given. What comes out, divide by the smallest. This gives a ratio of what? This gives a ratio of whole numbers, so good. We just choose the correct empirical form. Remember, if it doesn't come out as a whole number, then you will have to multiply all through by something to change them into whole numbers. Again, what is the empirical formula of the oxide formed when 2.6 grams of chromium produces 3.8 grams of the chromium oxide? That means the chromium is 2.6. What about the oxygen? It is the rest of the 3.8. So oxygen is 1.2. Again, divide by the mass number, which is already given. What comes out, we divide by the smallest. Now what do we get? We're going to get 1 to 1.5. The 0.075 divided by 0.05 is 1.5. Please don't say it's 1 and don't say it's 2. Don't round up or round down. We multiply through by 2, then it comes out 2 to 3. That means my empirical formula is Cr2O3. Are we okay with all of that? Okay, in this question, we're told that excess calcium carbonate was added to 100 centimeter cubed of 2 mole per decimeter cubed hydrochloric acid. The mass of calcium chloride crystals obtained was 10.4 grams. We are given the molar mass, that's the MR, molecular mass of the compound. What is the percent yield? And we said in order to get the percent yield, we should calculate how much we should have obtained. So how much is the product supposed to be? We have information about hydrochloric acid. We get the number of moles of hydrochloric acid. Concentration times volume. Volume was divided by 1,000. That gives 0.2 moles. Now, that means if I look at the equation, it's very important to go back to the equation. You will find that when we write a balanced chemical equation, 2 moles of HCl would give 1 mole of calcium chloride, and that means the number of moles of calcium chloride is actually half of that of HCl. So now I know number of moles of calcium chloride is 0.1 mole. What are we asked to get? We're asked to get the mass. How do I get mass? Mass is number of moles times MR. I multiply the number of moles we got by the MR given. That says I should have obtained 14.7 grams. But how much was actually obtained? He says the mass of calcium chloride obtained was 10.4. So the percent yield is the actual yield obtained, 10.4, over the theoretical yield according to the calculation times 100, and that indicates that we had 70.7% yield. This question says 0.99 gram sample of 1,2-dichloroethane was completely hydrolyzed and silver nitrate was then added to produce a white precipitate. If you remember from the organic, if I have 1,2-dichloroethane and we add silver nitrate, that gives a precipitate of silver chloride. Because the chlorine reacts with the silver ions, that gives silver chloride. So if we have a certain mass of 1,2-dichloroethane, I can get the number of moles, mass over molecular mass. Then I can say that according to that equation, because I have 2 chlorines, then I will need 2 moles. So the 2 moles of silver ions would give 2 moles of the precipitate, and that means my number of moles is twice the number of moles of the compound. Now I have number of moles. What are we supposed to get? We're supposed to get mass of AgCl. Remember, the precipitate is that of silver chloride. So number of moles times the MR of silver chloride, that gives me this mass, 2.868 grams of precipitate. Are we following? Okay. Next question, the Avogadro constant is equal to the number of which of these? Again, remember, we said the Avogadro's constant is either the number of molecules in 1 mole or the number of atoms if what? If we have monatomic element. Not the number of atoms in any element or the number of atoms in a compound or the number of ions in an ionic compound, because the ionic compound could have several number of moles of ions. So remember that the Avogadro's constant is the number of molecules in 1 mole or the number of atoms if the molecule is monatomic. Okay. This question says 100 centimeter cubed of methane is completely burnt in 400 centimeter cubed of oxygen. What is the final volume of the gas mixture? And we're told that all volumes are room temperature and pressure. Now, I want you to remember that when we have all of them gases, I can relate directly with volumes, because we said the volume of 1 mole of any gas is 24 decimeter cubed. So all volumes can be related directly. I don't need to change it into number of moles and then relate the number of moles. And this applies only to gases. So if we're told that we have 400 centimeter cubed of oxygen, and I'm starting with 100 centimeter cubed of methane, according to the balanced equation for combustion, 1 mole of methane reacts with 2 moles of oxygen. And that means if I put 100 centimeter cubed of methane, it will need only 200, not 400. And that means the 400 is excess. So I have 100 centimeter cubed of methane. It needs to react with 200 centimeter cubed of oxygen, and it will give how much of carbon dioxide? Again, carbon dioxide is a gas, so it would give 1 mole, so 100 would give 100. Remember, we're not including water. Why aren't we including water? This is at room temperature and pressure. Water is not a gas at room temperature and pressure, so I cannot relate it to the volumes of gases that we're relating. So that means the 100 centimeter cubed of methane, all of it will be used up. And we will use up 200 of the oxygen, but I put 400, so I still have 200 more excess of oxygen, plus the 100 of CO2 that we formed in the reaction, and that means the final gas mixture would have a volume of 300 centimeter cubed. Okay, how many moles of ions are present in 30 centimeter cubed of 0.025 mole per decimeter cubed of barium hydroxide solution? We're given information about barium hydroxide. That means we should be able to get the number of moles of the barium hydroxide. But we're required to get how many moles of ions. And when you write the equation, you would realize that barium hydroxide solution, when it ionizes, it forms 1 mole of barium ions and 2 moles of hydroxide ions. So if I had 1 mole of barium hydroxide, I would end up with 3 moles of ions. So let's get the number of moles. Number of moles is concentration times volume. The concentration is 0.025. Please do not forget to divide the volume by 1,000. This gives me the number of moles of barium hydroxide. But we are required to get number of moles of what? Of the ions from the equation. 1 mole gives 3 moles of ions. So the number of moles of ions is that number of moles times 3, and that gives the number of moles of ions. Of course, if the question was asking for how many ions or what is the number of ions, then I would go on and multiply that number of moles of ions by Avogadro's constant. Okay, we're going to stop here for now, and we will meet again to do another set of questions and answers on chemical calculations. Thank you for listening.